So let's have a look at combination in more details. So there are two types of combinations. The first one is combination without repetition. For example, we need to pick two lottery numbers out of these 6 numbers. And as you can see, these 6 numbers are all different: 2, 14, 15, 27, 30, and 33. So those are 6 different numbers. Therefore, no numbers will be repeated. Therefore, we say that this is combination without repetition. There is also combination with repetition. For example, we need to pick 3 coins out of these 5 coins in our pocket. As you can see, we've got 3 5s and we've got 2 10s. So which means that if we pick out 3 coins, there might happen, and actually it will happen, that some of the coins will be the same, so some of the coins will be repeated. So this is combination with repetition. So on this slide, you can see the formula for the combination without repetition. So N, this is the total number of objects, and K, this is the number of objects that we would like to select. And for example, let's assume we need to choose 3 team members out of 10 people. So the total number of people or objects is 10, and we are selecting 3 people. So we get C, 10, 3, binomial coefficient of 10 and 3, and so we, instead of n, we substitute 10 and we divide it by 3 factorial, and in the brackets 10 minus 3 factorial. So when we solve this simple equation, we get that the total number of ways that team members can be selected out of 10 people is 120. And on this slide, you can see combination with repetition. So the difference between the previous formula is this part of the binomial coefficient where we have n plus k minus 1. And as an example, we can consider the choice of 3 scoops of ice cream from 5 flavors. I think you can agree with me that we can have different types of ice cream. We can even have 3 scoops of the same ice cream, or we can have 2 scoops of one ice cream and 1 scoop of the other ice cream. So in this case, some ice cream can be repeated. Therefore, this is the case of combination with repetition. And when we substitute everything into the formula, so we are choosing 3 scoops out of 5 flavors. So we insert everything into the formula and we get that we can get 35 ice creams of different flavors or different combination of scoops. And here I have presented some other examples of combinations. For example, we can choose 3 out of 10 sports people who can win a medal in a competition. And in this case, it doesn't matter whether these 3 people get gold, silver, or bronze, so they get the same type of medal. We can also choose 2 representatives out of 100 students. And again, in this case, it doesn't matter in which order we select those 2 people. And we can also choose 3 desserts from a menu of 10 desserts. So once again, in this case, it doesn't really matter in which order we choose desserts. We can even repeat some of them, which will be combination with repetition.